All right, first, I have a question. Those people who were working with Excel that I was having trouble with on Monday, did you figure it out? Or are you still struggling?
No, I figured it out.
Figured it out? Okay. Good. So apparently if you're still struggling, Stephanie has the answers. Is that a fair assessment?
Sure.
Okay, all right. Any questions? No graph with today's lab, I'm sorry. All right, we last left off with, I guess we just did scalars versus vectors, and I gave you names of things that were automatically scalars or automatically vectors. That was the last thing, right? All right. So one way to know that you're dealing with a vector is by having that symbol above it. There's one of the videos where I go through a couple other different symbols, but that's the one I tend to use in class, just because it's easier to write than any of the others. Tells us.
Good morning.
Good morning. Brianna and the list. Oh, Crystal. All right. With June, have you any questions before I keep going? Actually, I opened up to everybody again. I asked before you walked in if there were any questions, but if you had questions. No, you're good? All right. Another way that you can tell with a vector, because vectors have two things. They have a magnitude and they have a direction. Now, magnitude, size, amount, there's something associated with it to indicate how much. So I can also represent a vector just by actually drawing an arrow. It's in a specific direction, it has a definite length to it. So when we're adding vectors, so we get into vector math here, when we add vectors, we can, the two ways that we will be dealing with it are, one, we will care about the size of the arrow, or two, we're going to write a number next to it to indicate how big it is. So, for example, I have a box, and I'm going to push on it with 3 newtons of force to the right. Well, this is a simple case. What is the total force acting on the box?
Is it 3 newtons?
It is indeed. So my total force, I can write that as the total force, 3 newtons. Well, actually, let's nitpick that. 3 newtons is indeed part of the answer. What's the rest of it?
Do the units change when it's total force?
No, units still are newtons. Do we have a magnitude? An amount? Do we have the amount of force?
Yep.
Okay. Do we have a direction?
Yep.
What's the direction?
To the right.
Doesn't say that here, bless you. So we would write to the right. Don't worry, we're gonna shorthand that. But for right now, we do need to indicate a direction. If I'm asking for the force and and I want the full vector, we do need to somehow indicate a direction. Right now, to the right. However, physicists and mathematicians really don't like writing that much. So we are going to come up with something better. Instead of saying to the right, what we're going to do is a little shorthand here, and I'm just going to draw a small little arrow to the right, and I'm going to put an I with a hat over it. In French, it's anyone taken French and know what that's called in French? Okay. If you're using LibreOffice equation editor, it's called hat. Matter of fact, in physics, it's generally called hat. This is spoken as I hat. When you see that symbol over it, that's a vector symbol, but that's a specific, gives a little bit more information. This tells us we are dealing with a unit vector. Whenever you see a unit vector, the main purpose of a unit vector is to tell you a direction.
Does just the hat tell you that, or does it have to be the I hat?
It's just the hat over some letter.
Okay.
If you just put a hat without any letter underneath it, that would
Well, I didn't know like a hat over an A meant something different.
that would
Okay.
be called a hat, and that's the direction of a hat is whatever you pretty much
Okay.
whatever you say it is. My mind's racing into when I would actually use a hat. Yeah, I'll try not to go into the obscurities quite yet. All right, so first off, all vectors, it is a vector, all vectors have a magnitude and direction. So the direction is to the right. Why is it to the right? Why is the direction of I hat to the right? Not the fundamental reason of why it's to the right. It is less sophisticated than that. I could have made I hat to the left. I could have made it up.
Because you chose to.
Pardon?
Because you chose to.
Yes. It's to the right because I chose it that way. Or if you want to be a little bit more dictatorial, because I said so. Sorry, flashbacks to parents. All right, so it's to the right. Now, if you want to make it, well, we'll do it to the left in just a moment. All right, so instead of writing all that out, I could have written 3 newtons I hat. Now, I hat is not always to the right. It is conveniently, as Rachel was saying, because the force is to the right, it seems most convenient to make I hat in the same direction.
Do you need to put an arrow under I hat, or is it just like, is it?
Oh,
is it assuming
up here,
that's- Yeah,
since I hat is the direction you decide, you do need to say which direction it is.
Okay.
I could have written it I hat like that, or I hat like that, but somehow I do need to draw a small little arrow indicating.
so like in your final answer, you'd put like an arrow to the side or underneath I hat?
No, because I hat is right there, I say,
Okay.
I hat means that way. So the arrow's already there, so that covers anything else I write on this board.
So if you're like writing out like a formula or your answer, would you indicate that first, which way I hat was gonna go?
I would recommend it.
Okay, cool.
Other questions before I show you yet another shortcut? The I hat thing is always good. The next one, can be used under certain situations. All right, now if we're dealing with a one-dimensional problem, like this one right here, I got a force going that way. It's not like I got a force up and to the right. It's a one-dimensional problem. I have one other shortcut I can take. I could just say to the right is positive or negative. And so in that case, this would be 3 newtons. And if you want to emphasize, put a plus sign in front. Getting away with just a positive or just a negative only works if it's a one-dimensional problem. If you got things going in 2 different directions, you can't do that.
Would a negative mean it's being pulled?
With a negative what?
Mean it's being pulled in the opposite direction?
It does mean opposite direction. Oh, you talking about the force pulling?
Yeah.
As far as push or pull, just from a language, that would be the same as that. Those would be the same thing. So, at this point, push or pull, it doesn't matter. All right, let's take the exact same problem. Is it on? No. It will eventually come on. All right, I'm about to erase some stuff. All right, so we have, it's to the right, you know, right versus left, that doesn't change. Except now I want to make to the left positive. Or actually, let's stick with the hat notation. I don't have to define the negative direction as was indicated by Caleb earlier. Negative just means the other way. So to the right is now in the negative I hat direction. So I would write this as negative 3 newtons I hat. Now, even though the negative is related to the I hat, saying it's opposite of whatever we say I hat is, traditionally you put the negative in front. Some students in the past have done 3 newtons, put the negative right there. The problem with this is that's a subtraction problem. If you want to put it there, make sure you put the parentheses around it. But traditionally, the minus sign just goes in front. All right, questions before I make it look harder? Make it look harder. Pleasure. Now what is the total force?
5
Keep going.
5 newtons, little I hat thing.
If you're gonna use I hat, what do we need to do first?
See what direction it needs to go.
So what do you wanna make I hat?
It's over right.
All right, so we'll put that up here, I hat. All right, so 5 newtons I hat. And that's the total force. Now so I'm gonna do the exact same thing, except I'm gonna do it slightly differently. Here, you're just looking at them, 3 newtons both to the right. If I want to find the total force, I'm just gonna add them. I have 3 newtons I hat, that's that one, plus 2 newtons I hat. That looks like a J there. Let's see if I can do better than that. And then it becomes just a basic problem here. I combine my terms, and I got 5 of those things. Just slightly more formal. And now I'm going to do it another way. I am going to let 10 centimeters equal 1 newton. And this is just setting up the scale. So I put this up. See how well that works. And I've got, not well at all. Still on erasing. All right, I'm gonna pretend that I measured it correctly. Let's see, so 20 is about like that. There's my 2 newtons right there. And I know, and if I'm doing it carefully on paper, apparently the marker on this board doesn't work as well. But 2 newtons here would be represented by a 20 centimeter long line. plus 3 newtons. So now when I'm adding vectors, this is adding vectors graphically, I do what is known as the head-to-tail method. So I start somewhere, I got my 2 vectors there, I start somewhere, I started here, I went to there, that's my 2 newtons. Now I start here, this is my new starting point. I'm gonna add 3 newtons to that, so I draw something that's 30 centimeters long. So full span plus a little bit more, so somewhere around there. Add my 3 newtons there. This is the head of the vector, like an arrowhead. This is the tail, the other end. I put head to tail. And so now when I want to figure out what is my final answer, I started here, I ended there. That should be 50 centimeters long, which translates to 5 newtons to the right. Now, so far, probably, I'm guessing, the vocabulary, most of you have not bandied about vectors when talking. But this should basically not be earth-shattering. But there is math involved. I have had students visibly shake. They've had to do math. So hopefully I'm not seeing anyone visibly shaking right now, so you're hiding it well, or you're good with this. Elena.
So if it's positive, do you need to indicate it with a plus sign, or is it just when it's negative? Would we need to put like
Plus sign's optional
Okay.
if it's positive.
Okay, so assumption is it's positive.
Yeah, just like
regular.
the math people.
Okay, cool.
There's only so far from the brainwashing the math people have done to me that I can go.
But the negative sign is not optional.
Correct. If it is in the negative direction, you must somehow indicate it's in that direction. And the negative sign is the simplest. I guess your options are you could write it out in words. Most people opt not to. Did I make it more confusing, or should I just say you're correct? Okay, any questions before I make it look more difficult?
Yeah, just one more question. So, if you were setting up this kind of problem to solve it from beginning to end, the things that you would need to do first would be to like show which way I was going, right? You need to put that like up at the top of the problem.
Yeah.
Okay.
Either that, or if it's a one-dimensional problem, the positive direction.
Okay.
If you want to go that route.
Cool.
All right. Oh, unit vector. I started down this path and I got sidetracked. It's a vector, so direction is what you say it is. What's the magnitude? All vectors have a magnitude and direction. What's the magnitude of a unit vector?
Size of the nodes.
Looking for a specific value. Hint, it's called a unit vector.
One.
Yes, no units, the magnitude's 1. All right, over here again, this time. What is the total force acting on it now? Keep going.
1 Newton I hat.
You want me to reverse I hat over here? There we go, now say it.
1 Newton I hat.
There we go, yes. So, they're going against each other, and there are a number of students who look at that and say, well, they got 5 newtons pushing on it, but direction matters. I got 3 newtons to the right, 2 newtons to the left, total is 1. So that would be, since to the right is positive I hat, I got 3 newtons I hat, plus negative 2 newtons I hat. So I got 3 minus 2, 1 Newton I hat. Doing the head to tail method. Actually, I can use this time. I got I'll still use the scale of 10 centimeters is equal to 1 Newton. So I have a 30 centimeter line arrow going to the right. And now, and it doesn't matter which one you start with. I started with the 3 newtons this time. I'm now here. I do 2 newtons to the left. So that's my negative 2 newtons. My positive 3 newtons. And my final answer, when I'm adding those two vectors, is where am I relative to where I started? Well, I started here, I ended here, so my result is a vector that way, which should be 1 Newton to the right. This sum, the sum of vectors, is called a resultant. I don't know why I capitalize it, but I do. Just another vocabulary word. If I talk about what's the resultant, I'm just asking what's the sum.
Will we be doing both of these methods when we solve these problems, or are they just like 2 different ways to solve the same problem?
There will be probably 50-50 chance there's gonna be a question on the first test where you're gonna have to do head to tail, because I'm not gonna give you sizes, other than I'm gonna show you the picture of when everything is correctly sized, and then you need to be able to draw it head to tail as best
Okay.
you can.
Yeah.
Mainly, the head to tail method is, for the more complex problems, is so that you have a general idea of what the answer is. So you just roughly sketch it out.
Okay.
And then you go, oh, my answer's those are completely different, something's wrong here.
Okay, that makes sense.
Other questions? All right. Let's make it a bit more difficult.